Hi, I'm Tim Gilbert. I'm your BUS320 instructor, and I wanted to talk to you about probability in Chapter 4. So let's take a look at probability. We're going to use a relative frequency approach. It's one of three types of probability calculations that we can make easily. There's a classical, relative frequency, and subjective. I like the relative frequency because it is real data, it's observed data, and it's going to bring you to the real world and apply in your work situations. So a couple of basic things underneath probability that are core aspects of it. That the law of large numbers, the more samples you get, the more likely you are to get true probability estimates. Just like somebody goes to bat twice and they hit once and strike out, you'd say, wow, there's a 500 hitter. Well, put them at bat 100 times and then see what their batting average is. 100 times will be a lot more accurate. And the certainty of probability always add up to 100%, and they range between 0 and 1.00 or 100%. We're going to look at 300 test subjects, and the subjects are users of marijuana, non-users of marijuana, and did they test positive or negative. So our first look at it from a probability standpoint is I've got 300 people here that have been tested. 48% were positive, 52% negative. We got those values by dividing 143, the positive test, by 300, got 48%. 157 divided by 300, 52%. So this data was provided to us. And we've got yes, admitting use, 41%, and no, I'm not a user, 59%, and that was 122. Yes, I'm a user, divided by 300, and 178 divided by 300 for 59%. And there's the two relative frequencies side by side, and the scales are a little off, but they do show the 48 and 52% do not exactly gel with the 41 and 59%. So it would be nice to know some relationships about these two aspects of the subject population, and let's take a look at how we can develop that. But this is a good, powerful tool, just getting this out on the table, getting the relative frequency charts. But a lot of times people stop there, and I think it's a mistake. So let's see what it would look like if we put it in our table. Positive test result, 143, negative, 157. We've got our calculations over here on the side. We've got our subject said yes to use or not. No, I didn't use. 122 or in 178, and we've got our calculations. But wouldn't it be nice to know who said they were a user and tested positive? And we've got that information. So if you keep your data as you collect it so that you can keep track of this, you can break things down. These all add up to 300. These are the numbers that added across to the row total. But yes and positive, 119. Yes and negative, 3. No and positive, 24. And no and negative, 154. Now we can see these relationships and we can count them up. But 3 happens to be 3 divided by 300. That would be 1% of our population. And 24 divided by 300 is 8%. Let's see what the other percentages are. But this is a false positive. 24 people who are non-users, if they're true in their self-reporting, tested positively. So that means either people are not telling the truth or we don't have a very good test. So let's see for yes to usage and a negative test result. Sure enough, there's our 3 divided by 300, or 1%. So if I randomly select a sample out of one person out of the 300, there's a 1% chance I'll get someone who had yes to usage and a negative test result. There's a 39.396 or almost 40% chance I would get yes to usage and a positive test result. And that makes sense. 119 out of 300. Then there's a person who said they're not a user and yet they tested positively. That's 0.08 or 8%, 24 out of 300. And then 154 out of 300, 0.513 or 51%. So if I just pick one subject out of the 300 people, those are the probabilities. 39, 1, 8, and 51, adding up to 100, those are the probabilities that I would get those combinations of outcomes. Yes and positive, yes and negative, no and positive, or no and negative. So now we've got two tools. We've got our relative frequency bar charts, and we've also got our relative frequency inside a cross tabulation, how things relatively stacked up for two conditions. Now let's put a third condition in there, and a conditional probability statement is its name. And let's see, if I give the condition of yes to usage, what's the likelihood they'll test positive? This is a different question than we answered previously. If I said yes to usage, what's the likelihood they'll test positive? Well, the probability of positive given, that's what that vertical bar means, given yes, and I'm going to put that given right underneath at 122, is simply 119 divided by 122, or 97.5%. So if someone is a yes to usage, the likelihood they'll test in a positive way is 97.5%. If someone is no to usage, the likelihood they'll test in a positive way, no to usage, given no, that's why I put that 178 in the denominator. What's the likelihood of a positive outcome? 13.4. And I did the remaining two boxes for the columns. If I made the statement, given a positive test result, what's the likelihood of yes? That's a different calculation. That's 143 divided into 119. But I wanted to show you just the columns. Given yes, 119 divided by 122, 97.5. Given yes, which is 122, and a negative test result, which is 3, 2.5. Given no, 178, divide that into 24 and get 13.4. And given no, divide that into 154 and get 86.5. So that's probability. Three different uses of probability in a very practical way. I'd love to see you use it in the OLP. So keep it in mind. I'm going to put together another little section on probability that will add on to this. But these are three fundamental concepts that you can use in your OLP, and I think they're at a level that's intuitive enough so that you can see a practical application. Take care.